Have you ever seen toy cars like this one? Unlike most toy cars, these don't run on batteries. Now if you think that sounds primitive, think again. There's a lot of science behind them. Take this rubber band toy car for example. It shows us how energy can be transferred from one store to another. We know that total energy remains constant in any process. It can go from one store to another, but the total remains the same. Energy can't be created or destroyed. But if that's the case, why do we hear about energy loss? Where does this lost energy go to? Let's take a closer look. This is a solar-powered toy car, and it's powered by, well, solar power. Energy from the sun, or in this case, this torch, ends up in the kinetic store of this toy car via the electrical pathway. The more energy it has in the kinetic store, the faster it moves. But not all the energy from the torch ends up in this car's kinetic store. Here's why. When the solar panel is warm, it transfers energy to the surroundings by heating and radiation. So if a system like a toy car is poorly designed, a lot of energy is dissipated into less useful stores. This means that only a small fraction of the energy is turned into useful work done. Scientists and engineers all over the world are devising unique solutions to minimize the amount of energy wasted, and Singapore is on it too. One creative way is to store the energy that isn't fully utilized so it can be used later. Welcome to the Experimental Power Grid Centre, or EPGC, on Jurong Island. Around me is an array of solar panels. These solar panels are a testbed for the EPGC to find innovative solutions that can integrate more solar for Singapore. Singapore lacks natural energy resources. Hence, more solar helps to diversify our energy supply, increasing our use of clean energy. Based on our geographical location, solar offers the greatest deployment potential. But like most renewable sources, solar is highly dependent on weather conditions. For example, when a cloud passes by and blocks the sun, the amount of energy captured by the solar panels decreases. We call this intermittency. It means that the power generated from the solar panel isn't constant. Not all the energy captured by the solar panels ends up in our homes. Some of it gets dissipated into less useful stores. Let's talk to an expert to find out how they are developing innovative solutions to mitigate intermittency and store excess energy from the sun.
EPGC supports the reliable integration of renewable energy, such as solar, into the Singapore national power grid. We are developing innovative solutions to enhance the use of solar. One method is through the use of energy storage systems, or ESS for short. You can think of ESS as giant power banks. By pairing ESS with solar, the energy that is captured during the day can be stored for later use at night. There are two main types of ESS at EPGC. We are now at the test bay where we house both chemical and electrical energy storage systems. These are lithium-ion and lead-carbon batteries, which are both chemical storage systems. This is an ultracapacitor, which is an electrical storage system. Solar energy is transferred to the electrical store of the storage system. Ultracapacitors usually have smaller energy capacities, equivalent-sized batteries. They can be used to respond faster than chemical storage systems, which are useful for minimizing variations in solar. In general, ESS can help to mitigate solar intermittency and meet electricity demand when needed.
So there you have it. You have just seen how we use ESS to make the most out of the energy we have. ESS is a game changer. It benefits the power system and consumers like ourselves. The ability of ESS to capture and store energy helps to integrate renewable energy like solar into our national grid. Through using ESS and designing creative solutions, we can reduce the amount of energy wasted. In summary, total energy remains the same and is never lost. The energy is just dissipated into less useful stores, often by heating our surroundings. Energy resilience is especially important in resource-scarce Singapore because it affects our energy security. This can be achieved with a culture of innovation by creating and developing solutions using cutting-edge technology. I don't know about you, but that sounds like a pretty bright idea.